Hey everybody, today we'll do another video, and today we'll do signals and system, but it's going to be a topic that is called convolution. If I can get a marker that works better. Convolution. Right? So we have two different convolutions. We have a discrete time signal. I think I introduced that last time, and also we have, I did not introduce convolution, but I introduced discrete time, and I think continuous time, I believe. But anyway, so basically, convolution can be done in the discrete time signal and also a continuous time signal. Okay, so we will do today basically continuous time signal. So we do, this is the convolution. So the convolution is, they say that some output y of t is equal to the integral of negative infinity to positive infinity, and then but then this one right here is important to understand. It's important to understand that the convolution is equal to this. Technically, okay, so let me redo this. Right, so, okay. So the convolution of two different signals, right? So basically the convolution is by, it is said to be some output of the signal y of t is equal to h of t, right, convoluted with another signal. In this case, you can consider it x of t, right? So, but in other words, it's kind of very abstract type of I would say thinking on this convolution mathematically, right? So let me get my book. So the book that I'm using, which technically I'm not following this book too much, but technically what this is that this is convoluted, right? And then, but this can be written with the integral of negative infinity to positive infinity. And if I have this function, right, this can be cumulative, right? This can be switched, right? So over here, but one of this has to get a variable that is a dummy. It's a dummy variable, which in this case we can say that h of t, right? And then h of t, right? Now we can say that it is multiplied by this function, but this one right here, it will get what is called x of t minus tau. I am introducing another variable tau, right? And then d tau. So I am taking the integral of these two functions, and then I am and then I am introducing this new variable, dummy variable, which is tau, right? And talking about this, And instead of using a book like this, specifically you have a teacher that doesn't help a lot, and a book like this, I would recommend you to use a book for dummies, right? Signals and System for Dummies will help more than some stuff like that. But anyway, so this is the definition for the convolution, right? Now, the question is, and it's similar to the continuous time signal. It's similar. It's just instead of using this, I'm sorry, the discrete time signal. This is continuous time. But in the discrete time, you will see the little bracket instead of just this parenthesis, right? Okay, so now we have this little thing here, right? So, right, so now we have to see what we can do, right? And also, there is a method using the same technique because we have to use integration, but it's called using the graphical representation also of the convolution, right? But we will have, so we will use this method along with the graphical part of it to help us out. So let's say that we had a signal, right? So then we have a signal like this. So this is, let's say for example, this is y, actually h of t, right? H of t, right? And let's say for example that the height of this rectangle is equal to 1, and this is 1, and this is 2, right? So this is now remember this is a function of t, right? So it's a t right now, right? Now I have another one which I think I need to make this a little smaller because I need a little more room. I need a little more room for the other one, right? So now so now we have, okay, so right here I need a height, right? Let's say that the height over here is 1, right? It's 1. And this rectangle at this point, right? It's 1. So now over here I have another rectangle, right? And this rectangle over here, the height is 2, right? And then this right here is 4. So 1, 2, 3, and 4. 1, 2, 3, and 4. Okay. So I am well, technically it's a concept, right? Almost multiplier, right? But remember, we're not multiplying we're not multiplying rectangles over here. We're multiplying signals. And also it's going to be based on an area according to this integral. Okay, so now what we can do is we will use a method is called flipping. Right? And also shifting. Right. So using those two methods, we will do something with this, right? And but before that, we have to do something, right? So before this, the first step that we need to do, is that I have to change this one to H tau. The red is the change, right? So with that being said, so this is x of t, this is x of tau, right? So this x of t, right now, but I need to change that. I am keeping it black just for you to see, but it's still, actually, you know what? Let me just change it without, right? So let me erase this. All right. Now this is going to be x of tau, right? I want you to understand this, right? So this is a very important step. Now that I have that, I can erase. I can erase this one, right? And then, of course, over here I had a t. I had a t. Now that t becomes a tau. Becomes a tau, regular. Becomes a tau, right? So becomes a tau. So this becomes a tau. It's a very important step. Right. So notice that now everything, most functions are tau, is not t. It's a Greek letter for t in Greek. It's a Greek letter, right? Just, it's called a dummy variable. Right? You will see in a minute. Now, we have to flip one signal. We have to shift and flip one signal. Now, as we actually do in integrals, we try to flip or deal with the signal that is less complicated. In this case, they are both rectangles, right? I will flip the most simple one. Well, I think this guy is the most simple one, right? This one is the more complicated, it's bigger, right? Okay, so now we can flip and we can shift, right? Now, okay, so if I flip, by flipping, I mean flipping means multiplying. So flipping means multiplying, right? So mean multiplying by whatever number, right? In this case, I'm going to flip it by 2, right? So multiply by negative, whatever number that is. Shifting or flipping, right? Whatever this, or you can say by negative or positive, depending what, where is the region that you want to find the area of. In this case, they're both positive, right? But what if this area was right here, right? And this area was right here, then you have to flip this on the other side, right? In this case, but you can say that multiply them by a negative or positive one, whatever, so I guess, right? So now shifting, okay, so shifting means adding a t. Okay, so adding a t value to this. Now remember that we have a tau. We have to add a t right here, right? So we have to kind of reintroduce that t that was original there. Okay, so with that being said, let's do that. Right, so let me do that. Okay, so in this case, I will be shifting, right? So I will be flipping h of tau. H of tau, right? So we're flipping h of tau, h of tau. Okay, so when I flip that, okay, so that means that I have to flip the region to this side. Let me just add something right here. This is the origin, right? This is the origin. So right here at 0, right? So this is tau, right? So tau right here too. That's okay, but it's just to represent this, right? So now I am flipping that, right? So I am adding this, and also I am adding t. So I am going like this, right? And then like that. Notice that this is not up to scale, but I mean, you can, unfortunately, I don't have a big room over here in this board, so, right, so right here, so I am shifting 2 units to the left. Actually flipping, I'm sorry, flipping. Multiplying by, I gotta multiply by -2 back, right? So when I multiply by a -2 back here, I get that this is a -2 on this side, right? So technically, this is negative, this is 1, this is 2, right? So it will be -2, right? So, but then we have to add t, and the t is going that direction. So therefore, it's going to be t. So t minus 2, and then t minus 2, and then this is just t, right? So this is a regular t. This is not tau. This is t. All right. Okay, so now, now that I have this, I have to look for something that's called the overlapping region. Right. So now I have to move this function that I have here flipped towards whatever I'm going to. Okay? So where is the one that I'm looking for? Well, it's in the 0 plus, right? Going to the positive, right? So that means I have to move this. Now, as you notice that in this region is nothing. It's an empty space, right? So therefore, we can say that in this space right here, when t is less than 0, when t is less than 0, right? there is no overlapping, right? So when t is less than 0, there is no overlapping. So technically it's nothing, right? So it's not overlapping. Why? Because I know that this is the first place where I need to pay attention to, and it's nothing there. From up to here is nothing, right? Now, I am moving forward. Now, when I move forward, right? Then I move this. I move this, right? So if this was -1, right? In this case, -1, right? Then I put -2 where the location -1 is. This is going to be look like this. So in this case, right? So and this has a height of 2, even though it's not to scale, like I say, but actually 1. I'm sorry, this is 1. This is 1, right? So now I have to move this. So now I am going to shift. This corner is going to be at this point. So now this is going to be like this. So it's going to go like this. So now this is -1, right? -1. And the approximate right there will be 1, I guess. Right, so maybe like that, right? And then I go across to 1. Right, so to that point, right? Now, you can see that right now I have an overlapping, right? So this is where I need to pay attention. Over here with no overlapping, right? T is less than 0, no overlapping. No overlapping. So right here, I don't know if overlap is spelled with a 1P, but I mean, this is not an English class, I'm sorry. Yeah, so whatever. Okay, so now I am moving forward, right? So I am moving forward, right? So the first step, we multiply -2, we got it, and then we add t, right, which means shifting, right? Now, but we moving that forward, right, until we get some area of overlapping. So right here was nothing because t is still less than 0, right? Right here, when we move this from -1 to +1, which you need 2 units, right? So this has been moved after being flipped. Now this has been moved to the other side. Okay, very important. Now t right here is greater than, so t, right? T is greater than 0, right? But you can say that greater or equal to 1, right? So t greater than 0, t is greater than 0, but less or equal to 1. Now, remember that this one is t, right? But then this point is when t minus 2 comes in, right? And this point right here is t. So t now is at that point. So at that point, t is already less or equal to 1. Now, think about this. Right? So think about this. So now I am shifting that, right? So now we have an overlapping, right? We have overlapping. At this point, right? So now what I can do at this point is the following. So I can actually create an integral to calculate that. And I can say that integral from 0, okay, so I can say that at t less than 0, no overlapping. So we have two cases, no overlapping. Right? Why? Because t is still over here in the region. I mean, okay, so t minus 2 is still here in this region, right? T minus 2 is still here in the region. So that's why I need to count up. I need to make a consideration of that. Now, so now I can say that y of t, I can call that y number 1 because I need to do a couple of different regions. I can say that that is going to be equal to the integral of from 0. I am starting from 0. Why am I starting from 0? Because this doesn't really count. I mean, this region right here, there's no overlapping. Over here is when overlapping is happened right here. Right? This is overlapping region. Right. So now I am taking the integral from there, from this to 1, which is over here is t. Right? Now, remember what it says. I have to multiply the two signals, right? I need to multiply the signals, the height of the signals. In this case, it's going to be 1 times 2 is 2, right? And why is the variable? That's a good question, right? The variable that I'm integrating to, so is d and is d tau. Why is d tau? Because that's what it's telling me, right? Now, let me do the integral for this. So y1 in this case is going to be the integral of that, which is going to be nothing but 2 tau, right? The integral of that to tau. But if I evaluate this, evaluating t for tau again, this becomes 2. I replace t for tau is going to be 2 small t, which is going to be 2t. And that would be the first one. Okay, now, let me erase this and move forward. So now, this is kind of tedious, but I'm sorry. That's, wait, this, unfortunately, yeah. All right, so now I am moving forward, right? Now this is going to be equal to, I am moving from here. So now I am t minus 2 is going to be equal, it's going to be a 1, right? So t minus 2 is going to be a 1. I'm sorry, a 0. Actually, no, a 1. I'm sorry, a 1. So t minus 2 is going to be a 1. T minus 2 is going to be a 1, right? Now, and I am going like this, approximately to the half of that, right? Which is 1 about here. And going forward. And I'm going to 3. Right? So alright, so now This is t minus 1. I'm sorry, t minus 2. This is t now. Notice that I still have another region of overlapping, right? So obviously there's no overlapping here, right? So now, so in this case, I can, whatever, this is the overlapping region, right? Right? And this is 1, and this is 2, right? So the height is 1, right? Yeah. So, okay. So now I do another integral. Now the integral is going to be from t. This t will end. This is another point. This t will stop until I get to the last point of region, which is 4. Then I have to consider the last point of that region, right? Before that, I have to consider t that is in between here, and yeah, so it's going to complicate the integral until I get to that one. Okay, so now I have considered the integral of y. This is y2 of t now, right? So which is equal to the integral of I am integrating now. This is, just think about it. This is a and this is b, right? So it's going to be b minus lower top minus top. So it's going to be top minus bottom. So it's going to be this minus this. So it's going to be so higher, so it's going to be b minus a, right? But so this is going to be t minus 2, right? And this is going to be t. The limit of integration now, right? And now I'm going to still get what? I am multiplying that times that, which is 2 again. So 2 tau. All right, so 2 tau, I'm sorry, I'm kind of jumping ahead of myself, is 2d tau, which is technically is going to be 2 tau evaluated at t minus 2 to t. When I do that, right? When I do that, I see that this is going to be equal to evaluating, right? Plugging t for tau. It's going to be 2. It's going to be 2t. It's going to be 2t. So it's going to be 2t like this, right? Minus 2 times t minus 2. So when I do that, I get that. So when I do that, I get that 2t minus 2t plus 4. So notice that t with that t cancel out, and I get that y2 of t, right, is equal to 4. Okay. Now, so that is the second shift, the second move that I'm making in that graph. Now, let me make the last one. So now my t minus 2 is going to be right here, right? So this is going to be my t minus 2. T minus 2. And I think right here you can consider, you don't have to like move your graph that way. You can actually pick different intervals, But I will say that for me it works better like if I pick that, so it's going to be like in this case it's going to be if I'm going to pick from here to here, so it's going to be out of the region, but it keep it consistent by 2 units, whatever the unit was for this, right? So okay, so now let me erase this again. All right, so it's tedious, but it is what it is. So all right, so now I'm going to go from here. So I'm going to go up, and then about that one, and about that one. So this technically is going to be 5, but I don't have to go to there, right? I'm telling you, right? So this is what the point I was trying to make. So just because I went to the other side of this line doesn't mean that I have to consider that line. This is outside the region already. This is not overlapping. In this case, it's no more overlapping. Why? Because this is the region, right? This is the main region that I'm considering. So right here is no overlapping. No overlapping. Right? So, okay, so no overlapping, right? But in this case, I have overlapping. This from 3 to 4, I have overlapping, right? So right here, I have overlapping. Right. So technically, so T is right here. But remember what I said, that T stop existing until I get to the last point of that region that I'm considering. So now, right? So now what I'm considering is this point, right? I'm considering from this, to 4. So now the new integral is going to be y3. And I just do this and so it's going to be y3 of t, which is equal to, now this is equal to t minus 2 to what? To 4. Why 4? Because this is the last point of that region, right? The last point of that rectangle. Multiplying the two functions again, I get 2. And then there's 2d tau, right? Integrating that, again, I get 2 tau, right? Then, plugging these values in there, I'm going to get what? I'm going to evaluate, right? So I'm going to evaluate that. Okay, so now I need to evaluate this integral, right? And now I am evaluating that integral between 4 minus 2, I'm sorry, t minus 2 and 4. Right? So when I do that, I actually also, I want to point it out too that I am still using the same theory, right? So in this case right here will be when t minus 2 is less, when t minus 2 is less or equal to 4, right? So I have overlapping. Overlapping, right? So I don't have any more overlapping after that, right? So I just want to, kind of clarify that. But anyway, so now, right here, I say that y3 now, right? y3, so y3, right, y3 of t is equal to, right, so I'm evaluating that at that point, which is going to be 2 times 4 minus, right, minus 2 times t minus 2, which is going to be equal to what? It's going to be equal to 8, right? So at that point, it's going to be 8. So it's going to be 8 minus t, minus 2t, right? Minus 2t, right? And then plus another, right here is 2, so technically that is 4, right? So it's going to be 4, right? So now that simplifies that y3, right, of t, in this case, is going to be equal to, if I have this math correctly. So yeah, that's negative, so that becomes a negative. Yeah, so that is nothing but 8. Now this is combined that and that is 12, right? So I gotta do that in one chapter already. So it's going to be 12 minus 2t, which is the same thing as negative 2t plus 12, right? So now with those values, so I have those values, right? So I have this 4, I have that 2t, and I have that. So I need to put those together because I need to graph this again. So I need this. So y1, y of t1 is equal to 2t, right? So that's 1. And then y of 2t, y2t is equal to 4. I need those values. Okay. So now I need this space. I need that space. So, okay. Right. So now I need to create a graph to represent that, right? So now, so right here, so now that we graph that, it's going to be with respect to t, and this is going to be y of t, right? So we are going to plot the two convoluted signals of these two. So now this is the last step. If your teacher asks you to plot the last convoluted signal, this is going to be the last step, right? So we know that from here we don't have anything, right? No graph, right? No overlapping, no graph, no plot, right? So basically it's 0, right? We don't have to worry about this, right? So, right, but we have to worry about this, right? So right here, so we say that a t is equal to 1, right? And I think the next one was a t was equal to 3. You can, so 1, and then 2, 3, 4. Okay, so t is equal to 1. Let's say, for example, if t is 1, you plot t is equal to 1, right? So then this is going to be equal to simply 2. But in this case, so it's a positive value like that, right? Now, but then we say that, so this is the slope for 2t, right? Now, so then the next one is y2 is equal to 4, right? So in this case, this is 4. This is 4, right? And this is 2t, right? Then we go at 1. At 1, we have, right? Then we go across. We go across. If I have a market that works a little better. And that is region right there. Not region, but the convoluted graph. Right? Up to there. This is when this is 4. And the slope is what? Is 0, right? So we have just kind of straight line. Up to this point, right? Then at this point, right? So if you think about it, so at that point we're going negative, right? We're going negative, right? So in this case, right? So think about it. You have 2t plus 4 plus 12, right? In this case, for example, right? If t is equal to let's say, for example, 6, then that will make that 12, right? All right. So I'm sorry. That would make that 0. Yeah, so that would make that 0, right? So yes, that would make that 0. Okay, so now so right here we're going down, right? So we're going down. Right? And that is the graph. This is 4. And this is negative. This is y. I don't know if I want to do it right here, but this is y of 2t. Right? And this is y of 3t, which is negative 2t plus 12. So it's a negative, right? So, and remember, we're dealing with this, right? So this is assuming that it goes positive, right? Because that's a plus 12, so assuming that this some y intercept somewhere, right? But we just dealing with convoluted singles, right? So in the so right here, so this one did not come out correctly, but we can make it kind of dropping this, right? So and make that a 3, right? So now that would be your convoluted signal for those two signals, right? And yeah, so that's how you deal with this type of problem. Thank you for watching, and remember right here, Jesus is the one that get all the glory, right? I don't know if YouTube like this, but I can care less if YouTube doesn't like it. I have to still say that Jesus is my Savior. And that's it. That's why this channel is Conservative Engineering Academy. We talk over here every once in a while. We talk about Jesus. Thank you for watching.